Hello my friends, and here we go with the final training for loop of our A3C model. And I have to say something, it is actually the last practical tutorial where we will be coding something together, because indeed after that we will be ready to visualize the final results. Not only we will run the training, but also we will visualize the final results. And since this is the exact same cell as in the previous implementations, well indeed we have nothing more to implement. So let's enjoy this final tutorial implementing that final training for loop for our A3C algorithm implemented for Kung Fu. Here we go, let's get started. And to finish in beauty, we're actually gonna implement something super cool that we haven't done before, which is the progress bar. So when we run the training, you will see a growing progress bar as we progress in the training. And we're gonna get that thanks to the TQDM module, but more specifically from the T-range function by the TQDM module. So there we go. We're gonna start with indeed the TQDM module, from which we call that T-range function, which will contain the exact same range as the range in our training for loop, meaning the range of iterations over which we will be training our A3C agents. And so that range is actually going to be from 0 up to 3000 iterations, and therefore I'm going to enter here 3001, because the upper bound of a range in Python is excluded, and it's important that we go up to 3000 included, because we're going to print the average score over 10 episodes every 1000 iterations, so we need to include 3000, okay? So that's the range of iterations of our training, and then we're simply going to add this shortcut name that we're going to choose to be progress bar, so that when we do the for loop, well, we can do directly the for loop in the progress bar. All right, so let's add some colon here, and here we go. Let's start that for loop. All right, so as we just said, we simply need to do that for loop in the progress bar, and therefore the loop variable here is going to be I for iteration, the different training iterations going from 0 to 3000, and so for I in not a range, but directly the progress bar. All right. And that's exactly the same as if we did for I in the range from 0 to 3001. Okay? So colon, and now here we go. Let's implement the for loop. And so now basically it's very simple. We just have to put ourselves in the shoes of our agent. And so let's do that. What would we do as the agent right now in this first iteration of this core training loop? Well, right now we are in a certain state. We are in this batch of states, which was reset, initialized thanks to the reset method called from our env batch object of multiple environments. Because indeed, remember that we are now not only one agent, but several agents interacting with multiple environments. And therefore, in fact, we have to put ourselves in the different shoes of these multiple agents. But what do these multiple agents have to do in each of these initialized states? Well, of course, it is to play an action, right, for each of them. And how can we do that all at the same time? For all these agents interacting in all these multiple environments. Well, by simply calling the act method from our agent object, that same object that was created as an instance of the agent class, but called on the batch of states. And so there we go. That's exactly what we're going to do. We're going to introduce a new local variable for our batch of actions that are being played. And then there we go. We call our agent object, from which we call that act method, which we implemented in the agent class, which indeed takes as input a batch of states, which are the initialized states in all the multiple environments in our env batch object. Okay, so here we go. Let's take our batch of states, because that's exactly what we're gonna input in our act method. All right, perfect. So now basically we play the actions in that batch of states. And so now what is the natural next step? Well, after playing the action, we reach a next state and we get a reward, and we know whether the episode is done or not. And so we're now going to get all these elements with a new local variables, which we're going to get thanks to the step method called, of course, from our env batch object. So here we go. Let's get first the batch of next states, then the batch of rewards, then the batch of dons, and then the additional information, which we're going to disregard with an underscore. All right? And so all this is going to be what exactly? It's going to be the output of the step method. But which step method? Well, of course, the step method that was just implemented in this env batch class, because now, indeed, we have just played a batch of actions from our multiple agents interacting with multiple environments, And therefore, we need that multi-environment step method that allows for our agent to step in the multiple environments they interact with. And that's exactly this one. And therefore, that's exactly what we're going to use now to get our batch of next states, batch of rewards, batch of done. So here we go. What do we need to call first? Well, that's of course our env batch object. All right, the multiple environments basically from which we're going to call indeed that step method. And that step method, let's have a look at it again. What does it take as input? It takes, of course, the actions, meaning the batch of actions that are played, that are selected from the multiple agents in the multiple environments simultaneously. All right, so back in the training for loop, let's enter, of course, here in the step method, our batch of actions. Perfect. So now we can move on to the next step. And what is the next step? Again, let's put ourselves in the shoes of our agents. Well, remember that we have to be trained to be more artificially intelligent at, well, fighting Kung Fu. So maybe it is the time to do the most important step of the training, which is, of course, calling the step method, but not from our env batch object, but of course from our agent, because that step method of our agent class is exactly the method that performs the step of the training, meaning that will compute the actor's loss that includes the advantage, but also the critic's loss, and then combine these two losses together to get the total loss, and then back propagating that total loss into the neural network with the Atom optimizer that will update the model's parameters, meaning the weights of the neural networks, in order to reduce that total loss and therefore returning at the next iterations better actions that lead to higher scores. And so that's exactly what we're going to do. But first, we're just going to do a little RL trick, a common practice used in reinforcement learning to stabilize the training, because indeed now we're dealing with actually high rewards, coming from the Kung Fu Master environment, and we need to reduce the magnitude of these rewards in order to stabilize the training. And to do so, we're just going to use a very simple trick. We're going to take our batch of rewards and we're gonna multiply this by 0.01, and that will reduce the magnitude of our batch of rewards, which are quite high, and that will stabilize the training. And we still need to optimize these same reduced rewards anyway, so that will not affect negatively the training. It will actually stabilize it and improve it eventually. All right, so that's the simple thing we had to do before that most important step of the training. And so now let's do it. Let's call the step method from our agent class in order to perform that model parameters update thanks to the Atom optimizer. And to do so, what do we have to do? Well, of course, we have to take our agent from which we have to call here it is, it's the last one here, step method. And the step method takes what as input? Let's have a look at it again to get a little refresher. Here is the step method from our agent class, and as we can see, it takes the state, the action, the reward, the next state, and done as input. But remember, be careful, these are actually the batches. Here we kept these notations to just simplify the formulas here and to make it more readable. But of course, these are the batch of states, actions, rewards, next states, and done. So that's exactly what we're gonna input back in the step method of our agent object, and we have to input them, of course, in the same order. So we have to start with the batch of states, then the batch of actions, then the batch of rewards, then the batch of, there it is, number 4 here, batch of next states, and then finally the batch of dones. Perfect, and that performs the step of the training, updating the model's parameters. Excellent, and now, what is the next step? A very important one that we must not forget. Remember that here we started from the initialized batch states, right, which were initialized here. So the agent plays its action from the batch of states, but then afterwards we reached the next states. And so, at the next training iteration, well, if we don't update this batch of states, well, we will still be in that initialized batch of states. So we need to update that batch of states to be equal to what, of course? Well, the batch of next states, right? So that's exactly what we have to do now in order to move correctly to the next training iteration. And so there we go. We take our batch of states and we update it to be the batch of next states. Here we go. All right, so now at the next iteration, when the agent plays its action, it will be from the right next states. Perfect. And so now, while the training for loop is completed, we have implemented everything that needs to happen in each training iteration. And so now we can do the final print to print the average reward over a certain number of episodes. I hope that rings a bell. So let's do it. But first, we're not going to print that average reward at every training iteration. We're going to do that every 1000 iterations, okay? So that actually we will see the progress bar growing 3 times. You will see it will be pretty nice. So let's do that if condition to check when we are at 1000 more iterations. And to do so, well, we're simply going to do a I modulo 1000, which I remind is the rest of the Euclidean division of I by 1000. And so if this is equal to 0, well then what? Well then that means that indeed we are at every 1000 iterations, and therefore we're going to print the average score. And so here we're going to do a simple print. We'll already have some nice dynamic print thanks to the progress bar. So there we go. Let's enter in double quotes the average agent reward, then some colon and a space. And then outside of the quote, we're going to add a comma, and then after the comma, the variable, which will give us indeed that average agent reward. And so what is that variable? Well, we don't have it directly. We need to use a last tool we implemented before to get that average agent reward. I'm sure you see which one it is. I'm talking, of course, about the evaluate function we implemented here, because indeed this function evaluate here allows us to evaluate, meaning return the accumulated reward over a certain number of episodes. And well, that's exactly what we need now. We need to compute the accumulated rewards over a certain number of episodes, and then what we can do is get the mean of those accumulated rewards over these episodes. And so that's exactly what we're going to do here. Back in the training loop here, for what will be printed, we're going to call our NumPy library first to get the mean function, because indeed we're going to take the mean of the output of the evaluate function over, well, let's say 10 episodes, right? This will make sense. Every 1000 iterations, we will compute the average of the accumulated rewards of our agent over 10 episodes, okay? If you want, you can choose 5 or even 3, but I think 10 is good. So let's take our evaluate function, which remember takes 3 arguments. First, indeed, our agent, which is our agent object created as an instance of our agent class. So our agent first, then it takes the environment, the Kung Fu Master environment, of course, created from the makeOn function, and then finally, the very important number of episodes over which we want to evaluate our agent in this environment. And well, as we said, we want to choose a number of episodes equal to 10, okay? This will give us a relevant evaluation of how the agent is doing. All right, so now guess what? Well, my friends, I have to say not huge congrats, but massive congrats, because we have just implemented the very last line of code of this course. Indeed, we're completely done with any line of code we implement over all the artificial intelligences we built in this course, because indeed now we are completely done with our training loop. So huge congrats, well, massive congrats for not only implementing fully the A3C model, but also for having reached the end of the practical sections with indeed a very powerful and advanced AI model. Okay, so now, without further ado, we're gonna run the training, but first let me say that the A3C model is actually much more powerful and much less compute intensive than the previous models, so we don't have to get Colab Pro or get a GPU. We can totally do this with the CPU. Actually, right now I am with the CPU, so that's totally fine. You will see that the training will be very fast, and plus we only chose 3000 iterations to train our model, and you will see that this will be way enough. Okay, so are you ready, my friends? Now it's time to get a good coffee or a good tea or a good OJ, sit comfortably in our chair, and there we go. Let's run the training of our A3C agent. And it is starting, and very soon we will see the progress bar starting. It will start at 0, of course, and then we will see it grow 3 times. First to reach 33%, then to reach 66%, and then finally 100%. And for each of these 33, 66, and 100, we will see the average reward computed over 10 episodes. All right, so it's going to start soon. Actually, you know what is happening right now? Since we did this, and right now I is equal to 0, well, 0 divided by the rest of the Euclidean division is 0. So actually it computed the first average agent reward of 440. And now there we go. We are, growing the progress bar from 0% to 33%, because indeed we are now going from iteration 0 to iteration 1000, right? Because 33% of 3000 is 1000. All right, and so now it's growing. The agent the agents are being trained in the multiple environments running in parallel. And at the end of this first, training window, let's say from 0 to 1000, well, we will get, there we go. Now the average agent reward is being computed over 10 episodes, but after 1000 iterations of training, well, actually 998. And in a second, we're about to get the average agent reward over 10 episodes after indeed 1000 iterations of the training. So actually, it takes a little bit of time to, compute that average reward over 10 episodes because we actually have to run these 10 episodes. So now the 10 episodes are running, the accumulated rewards are being collected, and then the average will be computed. And there we go, we get an amazing average agent reward of 980. That's super amazing because indeed, already 500 was a good threshold of what's good enough in this environment, just like in Pac-Man. But now I'm actually very impressed to already observe 980. And that's thanks to the, multiple environments running in parallel and training our agents. This is absolutely powerful. And now we're almost at 67%. There we go, reaching 2000 training iterations. And now the 10 episodes are running and the accumulated rewards are being computed. And then the average of these accumulated rewards over these 10 episodes will be computed to be returned in a few seconds. So now this is exactly what is happening. We're about to get the average agent reward over 10 episodes, but after 1998 training iterations. All right. So now it is being computed, and in a second, in a few seconds, we'll get the average agent reward over 10 episodes after 2000 iterations of the training. All right, it's coming in a few seconds. It's being computed now. The agent is running on 10 episodes and then accumulating the rewards, and then the average reward is being computed. And in a second, it will be printed here. And there we go, 1040. That's amazing. Another very great score. The average reward is increasing. That's absolutely amazing. And now finally, we are reaching the last stage. We are in the last stage of the training from the 2000 iterations to the last 3000, and 90% already reached, and we will get finally the average agent reward thanks to the 3001. It was important to keep 3001, otherwise we wouldn't get the final average agent reward being computed over the last 10 episodes that are run to evaluate our AI. And so let's hope that we will get more than 1000. That would be amazing, so that we can really finish this course with a good note. That would be indeed really amazing. So now remember, the 10 episodes are running. The agent is running on 10 episodes now, and then the accumulated rewards are being computed, and then we will take the average of those accumulated rewards, but this time it's actually after 3000 iterations of the training. All right, so we're about to get the average agent reward over these 10 episodes after 3000 training iterations. What will it be this time? Will it be higher than 1000? And no, it is actually 940, but that's really, really good. We reached some amazing rewards here, and as you can see, it was pretty fast. So now I'm just too excited to see the final results in the video. So if you don't mind, well, actually, I would like to already execute the cell in part 3, visualizing the results, because this is actually the exact same code cell as the one we used before for our deep Q-learning and deep convolutional Q-learning models. As you can see, with the show video of model function first, and then the show video function, and then we call the show video, and we get the video of course, our new environment being Kung Fu Master. So, are you ready to do this? Let's do this now, right? Let's run the cell and let's enjoy the very final video of our AI fighting Kung Fu after indeed a very good training. All right, that's the video and it is starting. Okay, so that's number of lives and that's the score. Right now it is punching some people. It just lost 1 life, but reaching a score of 200, 400. Now punching some more people, 800, 1000. Really, really good. 1000 and only 1 life left. Be careful. Oh, 1200. Punching, dodging some bullet. Very good. Jump up, fight, Kung Fu. Okay, it has more life. Okay, 1300, and punching more, 1300, 1500. Who says better? And done. All right, so that was pretty cool, no? That was our AI fighting Kung Fu. Maybe not as good as Neo, but I'm satisfied with the result because indeed we had a very nice training before the fight, right? Remember, we reached that final score of 1040, so that was really, really good, and that's how we could get that final reward of that single game, on that single episode of 1,000. How much did we get again? 1,600, no, or 500? 1,500. So that's really good. Massive congrats again. Now we're going to do that final ChatGPT tutorial to see if it has some recommendations for our AI, or if it suggests another architecture, or maybe some other tools or features or tricks to improve the model. And also I'd like to say that if you manage to tune the model or figure out some ways to improve the final score, well, please share that in the comments. I'll be actually super happy to even record a new tutorial to show the improvement. Alright? So I'll see you in that next tutorial with ChatGPT, and until then, enjoy AI.